An AI might seem like magic, but we're gonna learn how it works using simple language. Hooray, StatQuest. Hello, I'm Josh Starmer and welcome to StatQuest. Today we're going to talk about how AI works in super simple terms. This StatQuest is brought to you by the letters A, B, and C. A always, B, B, C curious. Always be curious. I also want to give a shout out to my big brother Mike, who inspired this StatQuest by asking a few great questions. These days, pretty much everyone is using AI to do all kinds of cool things. For example, Squatch might enter the prompt, "Write a poem about Squatch." Squatch is cool. Squatch is great. When it's time for StatQuest, Squatch is never late. Josh, this AI just wrote a cool poem about me and it's totally awesome. However, I'm wondering how it works. Can you explain it in such a way that even a big, fluffy monster like me can understand? I'll do my best, Squatch. We'll start with a super simple example and build from there. Bam! Imagine we had two companies and we counted the number of stores they had. The company on the left had 5 stores, and the company on the right had 15 stores. Then we counted up how much revenue each company made. Next, imagine we connected those two dots with a straight line. Now, if someone came along and said, "I heard of a new company that has 10 stores," then, by drawing an arrow from the new company up to the straight line, and then drawing another arrow from the straight line over to the y-axis, we could predict that the new company makes 7.5 stat bucks in revenue. Using the straight line and drawing arrows isn't a terrible way to make a prediction. But drawing the arrows and measuring things by hand is a little tedious. Alternatively, we could use the equation for the line to do the same thing. The equation is a little easier to use because all we have to do is plug in the number of stores, get a computer to do the math, and the output is the predicted revenue. So, in this example, we could plug in the number of stores for the new company, 10, and then a computer does the math, and we get 7.5 as the predicted revenue. So, here we have an example of using an equation for a line to make a prediction. Note, before we move on, I want to point out that we don't need the original data to make new predictions. In other words, after removing the two data points, poof, we can still use arrows from any point on the x-axis to find the corresponding y-axis value and the predicted revenue. Likewise, we can plug any point on the x-axis into the equation for the line, do the math, and get the corresponding y-axis coordinate and the predicted revenue. In other words, the only thing we need to make a revenue prediction are these two numbers. The first number is the slope of the line, and the second number is the y-axis intercept. Now, I know it might seem crazy, but the straight line and its corresponding equation represent a very simple AI. But Josh, how can you call a straight line an AI when all it does is predict revenue? A real AI can write awesome poetry. That's a great point, Squatch. However, let me show you how this straight line and this super simple equation are related to the AI that we use to write awesome poetry. We'll start by going back to the original prompt that Squatch wrote for the AI. Write a poem about Squatch. When we give an AI a prompt like this, then the first thing the AI does is take that prompt and convert it into numbers. This is because, fundamentally, computers only work with numbers. These numbers are then used as an x-axis coordinate for a graph, and the corresponding y-axis coordinate corresponds to the first word in a poem about Squatch. Note, if we changed the prompt from write a poem about Squatch to write a good poem about Squatch, then we would end up with different numbers and a different x-axis coordinate, and thus a different y-axis coordinate. And that corresponds to a different first word in the poem. In other words, slightly different prompts can give us different poems. Also, to be clear, the output isn't exactly the word once. Instead, it's just a high probability that it will select the word once over other words. In this case, there's a high probability that the AI will output the word once, but it might output something else instead. By having a little variation in the output, the AI can seem a little more human, since we don't always say the same things either. Anyway, going back to the original prompt and the original output, we can then add the first word in the poem to the original prompt, convert the words into numbers, use the numbers as an x-axis coordinate, and then find the corresponding y-axis coordinate, and that ends up being the second word in a poem about Squatch. To predict the next word in the poem, we add the predicted words to the original prompt, convert the words into numbers, use the numbers as an x-axis coordinate, find the corresponding y-axis coordinate, and that ends up being the third word in the poem. Likewise, the remaining words in the poem are predicted by finding their corresponding y-axis coordinates.
Josh, I find it hard to believe that's all there is to it. If all AI needed was a straight line, then why do we have huge data centers to run it?
That's a great question, Squatch. Now that we know the main idea that an AI converts your prompt into an x-axis coordinate, and then uses the corresponding y-axis coordinate to generate the output, we can talk about the differences between this straight line and the AI you use to write poetry. First, our straight line started out as just 2 data points. In contrast, the AI that writes awesome poetry starts out with trillions of data points.
Josh, that's not even 50 points.
Squatch, there's no way I'm drawing trillions of points, so you'll just have to use your imagination.
Okay.
Anyway, when we only have 2 points, the best we can do is fit a straight line to them. In contrast, when we have trillions of data points, we can fit a much more complicated shape to the data. In other words, instead of a super simple equation for a straight line like we had before, the AI uses a much more complicated equation. Oh no, it's the dreaded terminology alert. When we fit a straight line to data, we have to find a good value for the slope, which in this example ended up being 0.5. And we have to find a good value for the y-axis intercept, which in this example ended up being 2.5. These two values that define the line, the slope and the y-axis intercept, are called parameters. So we would say that the straight line has 2 parameters. In contrast, our fancy poetry writing AI can have trillions of values that we multiply and add to the input. And because each value that we multiply and add to the input is called a parameter, our big, fancy poetry writing AI can have trillions of parameters. So, the next time ChatGPT or DeepSeek or Grok or whatever releases their next big AI, and they say, our new AI has 2.3 trillion parameters, what they're basically telling you is how big their fancy equation is for writing poetry. Now let's summarize the first main idea of how AI works. We start out with trillions of data points. Then we fit a big, fancy shape to the data, which we can write out as a big, fancy equation. And once we have the equation, we can get rid of all of the original data. Poof. Then, when someone gives the AI a prompt like, write a poem about Squatch, the AI starts by converting the prompt into numbers, which are used as an x-axis coordinate or input value to the big fancy equation. Then we do the math to get the y-axis coordinate or output value, and the output corresponds to the first word in our poem. Bam!
Okay, I think I'm starting to understand how AI works. But where does all the data come from, and how do we fit a shape to it?
Great question, Squatch. And to answer that, we need to learn how to build an AI. If we want to build an AI, then we're going to need some data, and at the start, we don't have any. So the first thing we need to do is give the AI some data. Most of the data used to build an AI comes from really large bodies of text, like the entire Wikipedia, and all of GitHub, and pretty much everything else on the internet you can get your hands on without being sued. And then we use that data to build an AI that can predict individual words. For example, we could start with the very first Wikipedia article, which is about something called ah, and use the first 4 words, ah was a Japanese, as an x-axis coordinate, and pair those words with the y-axis coordinate for the next word, girl. Combined, the x-axis coordinate and the y-axis coordinate give us a specific data point on our graph. The idea is that we want to get the AI to take ah was a Japanese as a prompt, then do some math, and ultimately predict the next word, girl. Likewise, we might use was a Japanese girl as an x-axis coordinate and pair those words with the y-axis coordinate for the next word, group. Combined, the x and y-axis coordinates give us another data point on our graph. And the idea is that we want to get the AI to take was a Japanese girl as a prompt, then do some math, and predict the next word, group.
Aha! Ah was a Japanese girl group.
You got it, Squatch. Anyway, we would just keep on using fragments from Wikipedia articles to create a dataset until we got to the end of the very last article on Z Grill. And we would use of horizontal points has been as the x-axis coordinate and changed the final word in the Wikipedia as the y-axis coordinate. And those 2 coordinates would give us this point on our graph. Ultimately, we'd end up with trillions of data points. Now that we have lots of data, we need to fit a shape to the data. In other words, we want to create a big, fancy equation that, ultimately, can write poetry. The bad news is that the shape and the equation don't just magically appear. Instead, figuring out the shape and the equation takes a ton of computing time, which takes a ton of electricity, which costs a ton of money. So let's talk about how this process works. Oh no, it's another terminology alert. Figuring out the shape and the corresponding equation is called training. Now let's learn how training works. So we start out with our data. And then, believe it or not, we just fit a random shape to it.
I guess you have to start somewhere.
That's right, Squatch. So, in this case, we start with a random shape. And that random shape corresponds to a big, fancy equation that has random parameters. In other words, at the very start, we just pick some random numbers and use those as the parameters for our big, fancy equation. Next, we measure the distance between the data and the random shape. For example, we would measure the distances between this point and the random shape, and this point and the random shape, and, ultimately, measure the distances between all of the trillions of points and the random shape. Based on those distances, we then adjust the trillions of parameters in the big, fancy equation just a little bit. And, as a result of those small changes in the parameters, we get a shape that fits the data a little better than before. Then we repeat that process. We measure the distances from the trillions of data points to the line, and then adjust the trillions of parameters a little bit. And, as a result of those small changes, the shape fits the data a little better than before. Then we just keep repeating the process until we get a shape that minimizes its distance from the data. Note, the reason we fit the shape to the data a little bit at a time, instead of all at once, is that the big, fancy equation is just too big and fancy to solve easily. Thus, the second main idea of how AI works is that we use a step-by-step method to fit a shape to a huge data set. Double bam! Now, just to be clear, this big, fancy equation is all we need to draw the shape that we fit to the data. And that means we can toss out the original data. Poof! As a result, we end up with just a big, fancy equation that represents the shape. Note, because we have trillions of data points and trillions of parameters to adjust, this initial training needs a ton of computing power and is very expensive. The good news is that, so far, we've done the hard and expensive part. The bad news is that our AI still isn't ready to write poetry. Even though we have fit a shape to the data and we have the corresponding big fancy equation, right now, our AI is only good at taking bits of Wikipedia articles and predicting the next word. For example, right now our AI can take "of horizontal points has been" and, after doing the math, correctly predict the next word, "changed." However, "of horizontal points has been" is way different from the prompt, "write a poem about Squatch," and the output word, "changed," might just be the worst poem ever written. So, even though we have done a lot of work, used a lot of electricity, and spent a lot of money on training our AI, there's still some work to do. And this work is called alignment. Alignment consists of training the model to generate reasonable responses to normal prompts like, "What's a good YouTube channel for learning about AI?" In other words, even though we have trained our AI to correctly predict words in Wikipedia articles, that's different from getting the AI to properly respond to the types of prompts that most people give it, like, "What's a good YouTube channel for learning about AI?" So we need to align our model from where it is right now, predicting words in Wikipedia articles, to where we want it to be, responding to prompts like this. The good news, however, is that we don't need a lot of data for alignment. And that means, relatively speaking, alignment is fast and cheap to do. The other good bit of news is that the process for aligning the AI is very similar to what we did before. For example, given the prompt, "What's a good YouTube channel for learning about AI?" the AI converts that to an x-axis coordinate, then the AI does the math to get the y-axis coordinate, which, because we haven't yet aligned the AI, corresponds to a pretty lame response. Horizontal. Ideally, we would prefer the AI to suggest that StatQuest is a good YouTube channel to learn about AI. And the y-axis coordinate for StatQuest is here, a little higher than the y-axis coordinate for horizontal. So we adjust the parameters in the big, fancy equation just a little bit because we don't want to undo all of the training we did earlier. And that changes the shape a little bit. And that gets us a little closer to the ideal output, StatQuest. So we change the parameters a little bit more, and that changes the shape a little bit more, and now the AI outputs our desired response. StatQuest. This is awesome. Our AI is now responding correctly to our prompt. However, we're not done yet. Now we add the output to the original prompt and convert all of that, the prompt plus the output from the AI into an x-axis coordinate. Then do the math to get the corresponding y-axis coordinate, which gives us...
Wait, I think I can predict what will come next.
Bam!
I knew it.
Because we got what we wanted, we're done aligning. And that means this is the final shape, which corresponds to this, the final big fancy equation. Now, when Squatch enters the prompt,
write a poem about Squatch.
The AI converts the prompt into an x-axis coordinate, does the math to determine the y-axis coordinate, and that ends up being the first word in a poem about Squatch. Likewise, the rest of the poem about Squatch is generated by the AI, which, fundamentally, is just a big, fancy equation. Bam! So, we've just seen how we can take an AI that starts out only being able to predict individual words in the Wikipedia and align it so that it can now answer questions and write poetry. However, because it's relatively inexpensive to align an AI, it's common to use alignment for specialized things. For example, starting with the same pre-trained AI that can only predict words from the Wikipedia, we could align it to help write computer code, or be a customer service bot for a website, or solve complicated math problems. Thus, the third main idea of how AI works is that it is aligned to do different tasks. Triple bam! Note, this StatQuest only focuses on the three main ideas of how AI works. However, if you'd like to know the details, check out these quests. Now it's time for some shameless self-promotion. If you want to review statistics, machine learning, and AI offline, check out the StatQuest PDF study guides and my best-selling books on machine learning, neural networks and AI, and statistics at statquest.org. There's something for everyone. Hooray! We've made it to the end of another exciting StatQuest. If you like this StatQuest and want to see more, please subscribe. And if you want to support StatQuest, consider contributing to my Patreon campaign, becoming a channel member, buying one or two of my original songs or a t-shirt or a hoodie, or just donate. The links are in the description below. All right, until next time, Quest on!